How many red balls we have? We have 5 red balls. If all the 3 must be chosen as red balls, then it is 5C3 divided by 20C3. A intersection B divided by P of A. So when you have over A, the denominator becomes P of A. If it is A over B, then the denominator becomes P of B. Probability of E into probability of F is equal to probability of E intersection F. Hence, we can call that they are independent events. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we are taking the revision on the chapter probability. So from the chapter probability, you will get 1 2 marks question and 1 3 marks questions. So let's see the distribution of marks from this chapter. So here from part B, that is 2 marks, you will be having 1 question. Part C, 3 marks 1 question. Total 5 marks question you will get. So let's see what are the type of question it may arise from this chapter. First question, we are under 2 marks question here. The probability of occurrence of 2 events A and B are 1/4 and 1/2 respectively. The probability of their simultaneous occurrence is 7/50. What is the probability? Neither A nor B occurs. So the questions on probability of mutually exclusive, conditional probability, probability of A or B questions carries 2 marks question. So here we need to find out the probability of neither A nor B. So we will write probability of neither A nor B like this. That is A dash intersection B dash. We know from De Morgan's law, that is by the De Morgan's law, A dash intersection B dash can be written as A union B whole dash. So therefore, I can equate the probability of A dash intersection B dash to probability of A union whole dash. How a complement can be written? Complement can be written as probability of A union B whole dash can be written as 1 minus probability of A union B. So that is, if E and E dash are complements, then probability of E and probability of E dash results to 1. So therefore, when we want any one of the quantity, we need to subtract it from 1. And for this, we have a formula, that is 1 minus probability of A union B is probability of A, probability of B minus probability of A intersection B. So in the question, they have given the values of A, B as well as simultaneous occurrence, that is A intersection B. Let's write the value. So 1 minus, so 1/4 plus 1/2 minus 7/50. So here on solving this, we will get the LCM as 100 divided by, so here it is 25 plus 50 minus 2. So that is equal to 1 minus 61 divided by 100. On solving, we will get it as 39 divided by 100. So therefore, the probability of neither A nor B is 39/100. Next question. What is the probability that there will be 53 Mondays in a randomly selected leap year? So leap year means 366 days. And for 1 year, we have 52 complete weeks. So 1 year means 52 weeks. So that is 52 weeks means 52 into 7, 364 days we get. So 364 days or 1 leap year, I can say. 1 leap year is 364 days, that is 52 complete weeks plus 2 days we will get. So from the remaining 2 days, the order of the days may be like Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. Again, it may be like Sunday, Monday. So, you have all these cases. The remaining 2 days may be any one of the form written here. So, therefore, you have 7 possibilities of getting the next consecutive days here. But from the 7 cases, you have 2 cases of getting Monday. So, therefore, probability of getting 53 Mondays will be, already you have 52 complete week, means you have 52 Mondays there, but here you have only 2 chance out of 7 cases. So therefore the probability value is 2 by 7. Hence the chance of getting 53 Mondays is 2 over 7. Next. One ticket is drawn at random from a bag containing 20 tickets numbered 1 to 20. Find the probability that it is a multiple of 2 or 5. So let's take A as an event of getting the multiples of 2 from the tickets 1 to 20. So how many numbers you have from 1 to 20? You have 10 numbers, that is 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. So therefore, the probability of A, that is getting even number, is 10 out of 20. So that it is equal to 1 by 2. Next we will take the probability of getting multiples of 5. Let me take it as B. So how many multiples of 5 we will get from 1 to 20? Only 4. That is 5, 10, 15 and 20. So 4 out of 20. So therefore it is 1 divided by 5. Now let's take probability of getting the multiple of 2 and 5. It should be multiple of 2 and 5 and nothing but intersection. So there are only 2 possibilities. One is 10, another one is 20. That is, you have 2 numbers which are divisible by both 2 and 5 from 20 numbers. So therefore it is 1 by 10. Now we need to calculate the probability of getting either it is a multiple of 2 or it is a multiple of 5. So for that we will use the formula probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So here it is 1 by 2 plus 1 by 5 minus 1 by 10. So here when you solve this, you will get it as 7 by 10 minus 1 by 10, which is equal to 6 by 10. On dividing, you will get 2 3s are 2 5s are. So therefore, the probability of getting a number multiple of 2 or 5 is 3 divided by 5. Next question. A bag contained 5 red, 7 yellow and 8 green marbles. 3 marbles are drawn randomly from the bag. What is the probability that all the 3 are red? So here in a bag we have 5 red, 7 yellow and 8 green marble. So that is total we have 20 marbles. From the 20 marbles we need to choose any 3 marbles. And they have asked you the condition that 3 marbles must be set. Then how we will write the probability? So that is probability of all 3 are red. So how many red balls we have? We have 5 red balls. If all the 3 must be chosen as red balls, then it is 5C3 divided by 20C3. That is the value of the event divided by total number of outcomes, that is 5C3 divided by 20C3. So we can also calculate it. 5C3 is 5 into 4 into 3 divided by 3 into 2 into 1. And 20C3 is 20 into 19 into 18 divided by 3 into 2 into 1. We can cancel here. Again, we can write 4 5s are 20, 20 cancels. So 3 divided by 19 into 18. That is equal to 342. So when you divide this, you will get the value as 1 divided by 114. So this is the value for the given probability. Next, If P of A is equal to 1 by 2, P of B is equal to 1 by 3 and P of A union B is equal to 7 by 12, find P of B over A. That is the conditional probability of B over A. So to find the conditional probability of B over A, we have a formula, that is probability of A intersection B divided by P of A. So when you have over A, the denominator becomes P of A. If it is A over B, then the denominator becomes P of B. So now we doesn't know the value of probability of A and B, but we have only A or B. So using the expansion of probability of A union B, that it is equal to probability of A plus probability of B minus probability of A intersection B. So here we have 7 by 12, 1 by 2, plus 1 by 3 minus probability of A intersection B. So if we shift here, probability of A intersection B is equal to, so here it becomes 5 divided by 6 minus it comes here 7 divided by 12. So the value is equal to, LCM is 12. So here it is 10 minus 7, which is equal to 3 divided by 12. So now we have probability of A intersection is 3 by 12. Again, when you cancel it, you will get probability of A intersection B is equal to 1 divided by 4. Now let us substitute here. The value is 1 divided by 4 and probability of A is 1 divided by 2. Cancels. So the value is equal to 1 by 2. So next question. A box contains 8 red, 6 green and 10 pink marbles. One marble is drawn randomly from the box. What is the probability that the marble drawn is either red or green? So we need to select only one marble out of 24 marbles, 8 plus 6 plus 10. And they have also given the condition that it must be either red or green marble. Now let's see here. So probability of getting red out of 24 marbles. So probability of getting red is 8 out of 24 marbles. Probability of getting green is 6 out of 24 marbles. So we cannot get probability of red and green because they do not occur simultaneously. That is, they are mutually exclusive event. If you pick red, you cannot pick green, or if you pick green, you cannot pick red. So therefore, the probability of red and green will become 0. Now we need to calculate probability of red or green. So that is only the sum of the individual probabilities. So that is 8 by 24 plus 6 by 24. That is equal to 14 by 24 or it is equal to 7 by 12. So this is one of the examples for mutually exclusive events where the probability of their intersection is 0. So these are the types of question they may ask you for 2 marks. Next we will move on for 3 marks question. So in 3 marks question, you will be having questions in the form of sub-questions. Each question carries 1 marks. Let's see what are the type of question you may get. 3 fair coins are tossed simultaneously. Find the probability of getting 1 head, getting at most 2 heads, getting at least 2 heads. First, let us write the sample space for this experiment. So what is the sample space? H, 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 T, H, T, H, T, H, H, T, T, H, T, H, T, H, T, 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 T. So these are the outcomes whenever 3 fair coins are tossed. Now the first question is, what is the probability of getting 1 head? So probability of getting 1 head. So you look at the outcomes here, it should contain only 1 head. So we have 1, 2, 3 outcomes from 8 outcomes. So therefore the probability is 3 by 8. Next is probability of getting at most 2 heads. So at most 2 heads means Maximum it can have 2 heads, minimum it can be 0 also. So maximum 2 heads is possible here, 1, 2, 3, minimum it may be 1 or 0. So 1, 2, 3, 4, 5, 6, 7 outcomes we have, at most 2 heads. So it should have maximum of 2 heads or minimum 0. So we have 7 outcomes there out of 8. So therefore the probability value is 7 over 8. Next is probability of getting at least 2 hits. So in which outcomes we have at least 2 hits? In the first, second, third, fourth. So we have 4 outcomes. In all the other cases there is no 2 hits. So the outcome should contain at least 2 hits. So therefore the possibilities is 4 by 8, that is equal to 1 by 2. So to calculate the individual probability, you will have 1 marks. So total you will have 3 marks for the questions. Next question. A card is drawn from a well-shuffled pack of 52 cards. Find the probability that card is blackjack, card is diamond, card is red. So now we need to find out card is blackjack. So how many black cards we have? We have 26 black cards. How many jack cards we have? We have 4 jack cards. So now we need to find out probability of black or jack. So let me take black as A or jack I will take it as B. That is probability of A plus probability of B minus probability of A intersection B. Now probability of A means getting black. So how many black cards we have? 26 black cards out of 52. How many jack cards we have? We have 4 jack from all the sets. So therefore 4 out of 52. How many cards we have where it is both black and jack? We have 2 black sets, that is one is from spade, another one is from club. So we have 2 jack cards, so out of 52. So when you add it and subtract with 2, the value is 28 by 52. So that is 7 by 13. So this is the probability of getting the card is blackjack. Next they have given the card drawn is diamond. What is the probability that the card drawn is diamond? So probability of getting diamond is, so we have one set of diamond, that is 13 cards out of 52 cards. So therefore the value is 1 divided by 4. Next we have probability of getting red. So how many red cards we have? We have 26 red cards. So therefore it is 26 divided by 52. The value is 1 by 2. Next question. The probability that India win a cricket test against Australia is 1 by 3. If India and Australia play 3 tests, what is the probability that India loses all the 3 tests? So here the probability that India win, that is P of W is given, is equal to 1 by 3. And my first question is here, India loses all the 3 tests. All the 3 tests means it is exactly opposite to winning the game. So that is, it is P of W complement. So which can be written as 1 minus P of W, which is equal to 1 minus 1 by 3, which is equal to 2 by 3. And they have given it loses all the 3 tests. So therefore it is equal to cube of this. So probability of W dash, probability of W dash, probability of W dash. So that is 2 by 3, 2 by 3, 2 by 3, which becomes 2 by 3 whole cube, or 8 divided by 27. Next they have given India win all the 3 tests. If it wins all the 3 tests, it means P of W, P of W, P of W. So that is 1 by 3, 1 by 3, 1 by 3, which is equal to 1 divided by 27. So next question they have given, India wins at least 1 test. So if wins at least 1 test means 1 or 2 or all the 3 matches it may win. So therefore the probability will be like win lose, lose, plus win, win, lose, plus probability of win, win, win. So here we need 3 tests here. So here also we have 3 tests. So therefore now 3 into probability of winning they have given us 1 by 3. So we can also take this as probability of losing the match. So which is nothing but 2 by 3. So here it becomes 1 by 3, 2 by 3, 2 by 3. Plus 3 into 1 by 3, 1 by 3, 2 by 3. And here again it is 1 by 3 into 1 by 3 into 1 by 3. So solving this, we will get the value as 19 by 27. So this is the probability of value that India wins at least one test. Next question, a die is thrown if E is the event number appearing is a multiple of 3 and F be the event, the number appearing is even. Then find whether E and F are independent events. Now here, let's write the sample space for the die thrown, that is 1, 2, 3, 4, 5, 6. Next, let us write the sample space of event E, which is a multiple of 3, that is 3 and 6. Sample space for F is multiples or number appearing is even, that is 2, 4, 6. So we have here E intersection F also. E intersection F is 6. So therefore here probability of E intersection F is 1 divided by 6. Now let's find out probability of E. Probability of E is 2 divided by 6, that is equal to 1 by 3. Probability of F is 3 divided by 6, that is equal to 1 by 2. Now multiply P of E into P of F. So that is 1 by 3 into 1 by 2, which is equal to 1 by 6. So therefore what we can conclude, probability of E into probability of F is equal to probability of E intersection F. Hence we can call that they are independent events. Next question, a bag contains 10 gold and 8 silver coins. 2 successive drawings of 4 coins are made. Find the probability that the first drawing will get 4 gold and the second drawing will get 4 silver coins if first one, coins are replaced before second trial, coins are not replaced before the second trial. So here let's take, we have a bag which contains 10 gold and 8 silver coins. So let's take the first one, coins are replaced before second trial. So probability of getting, so 4 gold and 4 silver. 4 gold and 4 silver. So this is first case. Here once the 4 coins are taken, it is replaced by. Now if we take 4 gold coins, so the probability is 10C4 divided by 18C4. Now again it is replaced back. So once the 4 coins are taken out, you will be having only 14 coins left there. But again it is kept back. So therefore the total count is again it is 18 coins inside the bag. Now we are selecting the silver coins. So for silver coins you have 8 silver coins, you need to choose only 4. And here you have 18 coins out of 4. So this is the probability for the first one. Now second one is here, coins are not replaced, that is without replacement. So without replacement, what happens here? So probability of getting 4 gold and 4 silver. So now consider the bag has 10 gold and 8 silver coins. So 4 coins are taken out. So that means 4 gold coins are taken out. So therefore the selection will be in the form of 10C4 by 18C4. So now in the bag you have only 14 coins. From that 14 coins you need to select silver coins. But you have 8 silver coins. So therefore it is 8 silver coins divided by, and here it changes to 14C4. Because here the coins are not replaced back. In the previous one, the coins are replaced. So therefore, the total selection will be 18C4 only. But here it will be 14C4 because the coins are not replaced. So this is the probability for the second case. So evaluate the value and write the probability value. Next question. A couple appears in an interview for 2 vacancies in the same post. The probability of husband getting selected is 1/7. The probability of wife getting selected is 1/5. What is the probability that both of them will be selected? Only one of them will be selected. None of them will be selected. So let's take probability of husband getting selected is 1/7. Probability of wife getting selected is 1/5. Next we will take probability of H dash, husband is not getting selected. So it is 1 minus 1/7 which becomes 6/7. And probability of wife not getting selected as 1/5 which we can write it as 1 minus 1/5 which becomes 4/5. Now let's answer the questions here. Now first question is both of them will be selected. That is, it is probability of HW. H and W means probability of H, probability of W. They are independent event. So probability of H is 1/7 into 1/5 which is equal to 1/35. Next, only one of them will be selected. So therefore here we write it as probability of H W dash union W H dash. That is probability of H, probability of W dash plus probability of W, probability of H dash. So here it is 1/7, 4/5 plus 1/5 into 6/7. So on solving this, you will get the value as 10/35. So that is equal to 2/7. The last question is none of them will be selected. So again it is probability of H dash and probability of W dash. So that is 6/7 into 4/5. So that is 24/35. So this is the value of the given probabilities. So remember how to write the independent events, and when it comes for only one of them, both of them, none of them. When it will be having both of them, it is in the form of P of A, P of B. So none of them is P of A dash, P of B dash. Any one of them will be P of A dash B and B dash A. So like this, you need to write out the individual probabilities and calculate the probability. So these are the few questions which may arise for your final examination from this chapter. We'll meet you in the next session with a new revision of the chapter. Until then, keep watching, keep learning, keep exploring. Thank you.